I'm happy the opportunity to do the presentation for you today. Let me start by saying just a few words about our group. I'm Jenny.
I'm Jane.
I'm William.
I'm Harry.
I'm Nelly.
The subject of our presentation is similarity stock price. Before we start our presentation, let's take a brief look at the agenda. We have divided our presentation into 4 parts. There are introduction, key techniques, finding, discussion, and conclusion. First, let me introduce our introduction. In our report, we have going to show user how to create the GBM module and the similarity module to analyze the data. The main purpose of this report is to understand how to write a module to evaluate the future stock price and has better understanding of the GBM module. This report looks to explain the process of using GBM motion in conjunction with Excel and VBA to create a stock price similarity. The aims are to simulate price paths that a stock may following using a geometric random walk model and how charge to intervariables can affect the price path. The 3 modules in our report. The first module is the farmer's work, includes the items what inverters input. And the second module is talk about the calculation of the current stock price. The last module is about the construction of charts.
And now let me introduce the key techniques. There are 3 parts in the key techniques, and I will introduce the first techniques. It is the geometric Brownian motion model. It has 5 assumptions, and the first is talking about stock prices can be observed at all time and they change continuously. And the second says that the future price of a stock cannot be predicted based on its price history. And the other 3 assumptions have the 3 different equations. And the first equation is talking about the proportional return. And this equation is for the third assumptions. And however, this is only applies to stocks over a short interval of time. And the second equation is for the fourth assumptions. It has 2 kinds of styles, and S0 is the stock price now, and ST is the price at time t. And furthermore, the expected value and the variance could also be calculated. The expected returns for the geometric Brownian model process are independent of the values of the process, just like it happens in the real world. And in the real world, the process is always positive. One of the reasons is the GBM model is used to financial and other processes that cannot be negative. And the GBM process do not assume any extra costs associated with changing values. Stock returns are a function of transaction costs.
We know that the geometric Brownian motion is frequently used in reaction of stock price. And here are some of the reasons why the stock price is described by a geometric Brownian motion. Firstly, the GBM process can react the stock price more reality. Then expectation of geometry, growing motions, and the stock price of process are independent. The results of the simulations are in agreement with our expectation. Last reason is calculation of geometry and growing motion process is relatively simple. Everything has two sides. GBM also cannot be fully achieved. There are two defects. In a real stock, price volatility changes over time, but in the geometry growing motion, similarity stock price do not change. In addition, in real stock price, returns are generally dissatisfied with the normal distribution, which presents the potential for great price volatility. Next, I will simply explain the preparation of code. First, we need to dim some values, such as stock price, time increment, expected return, and volatility. And then we input data and assign the values. We select format structure to work because its structure can use for loop to perform repetitive tasks. And in the preparation, we used to use a few formula and calculate the K and the new stock price, certain components. The specific formula will explain by next group members. Source code, the computer will generate stock price based on the number of days and the computer working. Come to the change in stock price, we inside the chat, we write code. There are 4 steps. First step is select an input data range, and then select input chat location. Next is select chat types, and the last step is define XY axis scales.
Hi everyone, I will introduce how to calculate a new stock price. Maybe you will ask what is the KV mean. And now I will explain this to you. K is the expected return minus volatility. Then the volatility to the power operation. Then the V is the volatility. EXP is the expected return. R drawn is the application of the model. Is a random module. It generates random draw from standard normal distribution. These are 2 other formulas. First one is to calculate the certain component. Second one is to calculate the uncertain component. We simulate 4 different data for the chart. We choose one to the example. We can see the red line is the certain line, is the straight. The blue line is unsteady. The green one is unsteady too. Next, we follow the Larry.
Hi, so I would like to introduce you guys with the findings and discussions. So we have 3 major findings and 1 opponent to discussion. The first, that the price are continuously in time and value. We will follow the chat to prove that. And secondly, the price of stocks are nominally distributed. We have the histogram to prove that. And the third, the future price of stock can be predicted based on its price in history. So it's same with the Markov process, which has the name of martingale in the finance mathematics. That the future price, it cannot be predicted based on the past price history. And one discussion we have is we have the test for 3 times calculation respectively with the different expected returns, which is 30%, 50%, 70%. And we found that there might be relationship between the expected returns and the uncertain components. We will show next. So this chart, you can see it's the exponential line chart, and the price follow the time periods. Also, the unit of time periods is days. And in the 72 days, the price is fluctuated. Sometimes it's up, sometimes it's down. We cannot predict any point like this one. We cannot predict the future price after this point based on the past price history, because the future price will be high or low. So these 3 simulations prove that. And also, we could say the time is price follow the time pass. It will be high or low, it's fluctuated, but follow the time passed, the price is changed. And also this 3 histogram, it shows how the price distribute in the trails area. So we have the 72 trails, and also the price is plot in this region. And you can see the U curve, inverse U curve, observably, and also it can prove that from the 3 chart, you can prove that the price of stocks is normally distributed. And this is our discussion. We use the pair chart to do the test. So we set the expected return small is 30%, 50% for the medium expected returns, and 70% for the high expected returns. So we count the uncertain number components which less than 0. We count the numbers is respectively in 25, 70, and 38. So also the percentage is in the 72 calculations, which respectively in 35%, 80%, and 53%. The following is a pair chart. So we seems that it can have the definition which met the medium expected returns can cause less uncertain components. It sometimes will be useful for the stock price predict. So overall, the full conclusion, first, the price are continuously in time of A value. And second, the price of stocks are normally distributed. Third, we have the continuously compound return for stock is normally distributed. It's a U curve. And finally, we have the discussion with the might be extremely high or low expected returns, matter with more uncertain components in the stock price. Thank you very much.